So good morning all. So this is Aluk Kumar from National College of Technology and Department of Computer Engineering. So now I'm going to tell about the direct implementation of file system concept. So what is a direct implementation? So in a direct implementation we have to using a linear list of the file names with a pointer to the data blocks, and it is going to similar to the program, and it is a time consuming to execute. So in a linear list the linear search time will be available, and it could keep ordered alphabetically by a linked list or use b plus tree. So using a hash table, so linear list with the hash data structure, so it is going to decrease the direct search time and is occurs the collisions situations where two files names hash to the same locations. So only good if entries are fixed size or use chain to overflow methods. So allocation methods, contiguous. So an allocation method refers to how disk blocks are allocated for files. First one is a contiguous allocation. So each file occupies a set of contiguous blocks, and it is a best performance in most cases. It's like a simple and only starting location and the length of the record. And the problems include finding space for files and knowing file size, and external fragmentation need for a compaction offline or a downtime or online. Contiguous allocation, so mapping from logical to physical. So we have a drive location and a directory location. So back to be exists a queue plus starting address a displacement into a block equal to r. So external based system, so many newer file systems use a modified contiguous allocation system, example Veritas file system. So external based file system allocate disk blocks in extents. An extent is a contiguous block of disk. So in extents are allocated for a file allocation, and the files consist of one or more extents within the external based systems. So allocation methods, linked list. So linked allocation, so each file is a linked list of blocks. It is in consist of files end at in a nil pointer, and it is no external fragmentation, and each block contains a pointer to next blocks, and it is no compaction and external fragmentation, and a free phase management system called when new block is needed, and improve efficiency by clustering blocks into groups, but it increase the internal fragmentations, and reliability can be a problem, and locating a block can take many input outputs under disk 6. It is allocation methods like linked allocation. It is a fat file allocation table variations. It is the beginning of volume hash table and indexed by the block numbers. So it isn't used to merge like a linked list, but it is faster on a disk and catchable. It's an allocation method. It is a new block allocation symbol with file allocation table of variations. In a linked allocation, so each file is a linked list of disk blocks. So blocks may be skirted anywhere on the disk. Example, block equal to pointers and the mapping equal to q and r. So block to be accessed by the qth block in the linked chain of a blocks. It is representing the files with the displacement into block equal to r plus 1. So this is the linked directory. We have a file start and end. So jeep is an file name. It is a start with 9, end with 25. So we have to link it with all the necessary blocks with all the necessary files. It is a linked allocations. File allocation table, we have directory in the test and starting name, and starting with and end name is fixable, and the file allocation technique is going to use the file allocation table. So index allocations are each file has its own index blocks, and the finder stuff to the developer. We have a 4 index means we have 4 index files. This is the logical view of indexed allocation files in a file sharing method. So example of index allocation, we have each you have an individual block, and individual block have individual linked allocation to another different files. So index and allocation need to index table, and it is a random access process and a dynamic access without external permutations, and but have a overhead of index blocks. So mapping from logical to physical. So in a file of maximum size of 256k bytes and the block size of 512 bytes, so we need only one block for indexing. Okay, so here a q and r. So q is a displacement into index table, r is a displacement into block table. So in a induction allocation, so mapping from logical to physical in a file of unbounded length, it is a block of size of 512 words. So linked scheme is individual in an index allocation. It is used to link blocks of index table. No, it have no limit on sizes. So q1 equal to block of index table, and r1 is used for follows. So q2 equal to displacement into a block of index table, and r2 is a displacement into a block of files. This is the one index allocation mapping format temples. So it is an index allocation of technical format of groups. We have outer index and index table and a file concepts. So this is the combined scheme of unique UFXs. We have a 4k bytes per block of 32-bit addresses. So here index blocks that can be addressed within 32-bit file pointers. So this is the references. So So how we perform the performance will calculate in the sample process. So we have is the best method is depends on the file access type. It is use can't use great for a sequential and random. So linked good for sequential, so not a random. So declare access type of applications with the selection either contiguous or linked. So in an index more complex and a single block of access could be required to index a block and rather than the data block of read. So when we go to index more complex, it is clustering can help to improve throughput and reduce the CPU overhead. So this is the performance of in a file sharing concept. Okay, so thank you.